Hey, this is Robert Quimby, and I'm going to tell you about astronomical catalog queries. So, as an astronomer, there will be many points in your career when you might have an object and you want to know more about it. You might want to know where is it on the sky and how bright is it, or you might have find something on the sky and you want to know, has anyone found that before? Is there a catalog object that matches that source? So today I'm going to show you how you can see if this is the case. So there are many catalogs online that have been composed from publications. So people have published various tables of data and they've been compiled into these online resources. So I'm going to give you an overview of some of those resources that are available to you. And then we're actually going to go through the exercise of, hey, there's a star, I know its name, I want to know its coordinates. And hey, I found something on the sky, it looks like a galaxy. I want to see if there's a known galaxy that matches these coordinates. And then I'll show you the AstroPy affiliated package, astroquery, and we can use that actually to do these queries directly from a Python session. All right, so the first catalog I want to tell you about is called SIMBAD. And SIMBAD is very useful if you want to do queries for objects in our galaxy, so stars and nebula, for example. So we can actually just go to the website here. The main website is actually this site out of France. And you can see that they give you all these different options for what you want to query for. So we can just start with this basic search here. And we can type in a query. I'm going to query for Vega. I'm going to ask for information about this star Vega, which you may know. So if we just type that in there, hit enter, and it gives me all this information here that you see now on the screen. So the first thing is actually it tells me its proper name, which is Alpha Lyra. So it tells me that Vega is a star and its name is Alpha Lyra. There are many, many names for Vega and for lots of astronomical objects. This is it's common to have multiple identifiers. Here's a list of the 62 identifiers that VizieR knows for Vega, ranging from Alpha Lyra to Vega to 1E 183515 plus 3844.3. I don't know why we do this as astronomers. It's just very convenient for us to give an object its own name, other than to go back and find if someone else has given a name before. So this is kind of a common. Vega has a lot of names, but other objects may have multiple names as well. So you can use this system to kind of resolve that. You can just type in any of these identifiers and it'll figure out that Alpha Lyra is what you're talking about. So on this page it's telling you the positions in different coordinate systems. So it's telling you in the IRCS or Icarus coordinate systems, in the Epic Equinox J2000, it's telling you that's the RA index right there, 1836 plus 38. It also is giving you the coordinates in a different equinox, in the 1950 equinox in the FK4 system. And this is, of course, a little bit different because of precession. You can give galactic coordinates here, give you proper motion, radial velocity measurements, parallaxes, spectral type. It's a A0 star. And it's giving you fluxes in magnitudes here. So these are UBVRI magnitudes, and they're all about roughly 0. For Vega, because Vega is a special star, a bright one too. So you can get all this information and more for these stars, and you can get references to publications where these were actually put out. And that'll tell you all you need to know about objects in the galaxy. But if you do want to look beyond the galaxy, if you want to look at other galaxies, for example, then the best source for you would be the NASA IPAC Extragalactic Database, or NED. So NED is a very similar interface. Again, it's tailored towards things like galaxies and AGN. And you can type in the name of whatever source you care about. So maybe M31, you want to look that up. And it'll search for you. And so it's finding that name M31 in its catalog, and it says, oh, I know Messier 31. Just like stars, there's a whole bunch of different names for this, the Andromeda Galaxy being a popular one, NGC 224 being another one. But it'll give you this overview page. It'll tell you where the object is in the sky, the RA index. This is in J2000. It'll tell you its redshift, which is negative. Here, if you notice, it's actually moving right towards us, towards the sun, at a velocity of 300 kilometers per second. It's coming right for you. And it'll tell you object type, it's a galaxy, and morphology of that. A lot of good information here about that object. And there's some, they give you the coordinates in different systems if you want it, in galactic or supergalactic or equatorial. They're all there for you. Okay. Another searchable archive that I want to bring your attention to is called VizieR, and I'm assuming that's the correct pronunciation of this because they capitalized the R, although I believe this again was started in France, and that should be VizieR if I know my French, which I don't. But I'm going to call it VizieR because they made this capital R, so why not? So this is again an online service that you can search through. What's a little bit different about this is that this is more tailored towards publications, so data tables from more recent publications. So you can go to this website, and again they'll have this nice form that you can search for all kinds of different things. Kind of the most basic thing is that you can put in a position of objects, just like we did before. You can type in M31, and it'll tell you all the catalogs it has in it, and it has many that contain that object, that contain M31 or whatever you typed in it. And it'll actually search within 10 arc seconds by default. You can change this, of course, of the coordinates. So first it'll look up the coordinates using something like NED or SIMBAD. It'll find the coordinates, and then it'll find all objects in catalogs, all catalogs that have objects within 10 arc seconds of that object. But we can do a different thing. We can actually do a more general query for a type of catalog. So if I know there's a catalog, I can type the name of the catalog and it'll find it for me. So there's a catalog called APASS, APASS, and I can search for that, and it'll give me the list of all catalogs that have APASS in the name. And here's two of them. This is the one I want here. This is the AAVSO Photometric All Sky Survey. So I can click on this link here, and it'll tell me all the different column names that have in this table. So this is just a big table. Every row is going to have all these fields as available. It'll give me the RA index. This is a catalog of stars. It'll give me RA index. It'll give me the brightness. So I can use this. This is a handy catalog for getting the brightness of some stars. So say I was observing some field like, here we go, NGC 891. This is a galaxy, but I want to find some stars that are nearby with known brightnesses so I can calibrate my observations. So here we go. Here's a catalog of 8. There's a table of 8 stars from this AAVSO Photometric All Sky Survey catalog. And it's giving me the RA's index of those. It's telling me the V-band magnitude, B-band, G, R, I, color. So a lot of useful information, and I could use this to, as I said before, calibrate the brightness of the objects that I observe in my images. Okay. So there's many catalogs. This is just one example of one particular catalog, but there are many catalogs for you to choose from. All right. So what we've done so far is we've been following links and entering data by hand in tables and then searching through the results on web pages. And that's great for a lot of things, but often you might want to actually just have a Python session and do this automatically. You might just have a loop of different object names or different positions in the sky, and you want to run queries to different catalogs automatically without doing mouse clicks. So there is a nice package that's available for this. This is affiliated with AstroPy, but it's a separate thing. It's called astroquery, and there's some online documentation about what you can do with this. And there's several different functions and classes, modules that it has to query different databases. So we can query SIMBAD, which you just heard, or VizieR, or SDSS, or NED. All these different modules exist to query each one of those resources. And so we can use this to do a query, but first you might have to install astroquery. It may not come pre-installed if you just are running astroconda for the first time. So what you can do is in a xterm type source activate astroconda, of course, to make sure you have the astroconda stack load. And after you've done that, all you have to do to install astroquery is just type pip install astroquery, and that should do it for you. There's another way, if you wanted to, you could use the conda, so you could do conda install astropy astroquery with the -c flag. But this is probably the easiest, just pip install astroquery. So once you've done that and you have astroquery in your session, you can import it. So let's do an import. And I actually want to import the SIMBAD module. So from astroquery.simbad import SIMBAD with a capital S. All right, and you just run that, make sure that works fine. So boom, I have now my SIMBAD module loaded, and we can do something with it. Let's do a query to find the coordinates of Polaris. So what we'll do is we'll do a SIMBAD query. So we're going to query an object, so we use a function called query object. So query underscore object. And then in quotes, we just type the name of the object, and I'm going to do Polaris. So if I run this query, what it's going to do is it's going to find all the tables you can find in SIMBAD relative to Polaris, return those, and I'm just printing out the result here. It found a link to an object called Polaris through SIMBAD. Its proper name is Alpha Ursa Minor, and this is the coordinates for it. There's the RA and there's the deck. Polaris, of course, is also known as the North Star. It's very close to the North Galactic Pole, but it's not exactly there. It's actually about 15 arc minutes away. 45 arc minutes away. So there's basic information about Polaris. And you can return this, you can return this into a variable like that, and then you can access this variable, this table later. So if you wanted the RA field, for example, it'll tell you the RA of the return value. All right, so that's an example of using of doing a query and getting the RA and deck for a known object. Well, let's say you know the RA and deck, but you don't know what the object is named. Well, we can do another search now. This time, instead of using SIMBAD, let's use VizieR, and we'll do a more general query. So first we got to import our module. So from astroquery.VizieR, we're going to import VizieR with a capital V. All right, so run that, make sure that works. Okay, we have our module loaded now, so we can do a query. So what we can do is we'll do a query based on a position on the sky, and for that I want a astropy sky coordinate object. That's just a convenient way to do this. So I'm going to define my position on the sky, to say POS for position, and I'm going to set that to be a sky chord. But first, before I do that, I have to, of course, import sky chord because it's not imported yet. So from astropy coordinates, I'm going to import sky chord. And additionally, I'm going to import the units, astropy units, as units, so that I can specify the units of the angles I'm going to be specifying. So we have this, this should be a capital C here, by the way. Sky chord, capital S, capital C. So I'm going to define now a sky coordinate, an astropy sky chord, and I'm just going to give it the coordinates. So let's say I found something at a right ascension of 12 3049.4 and a declination of 12, 23, 28. Okay, so I can just specify that as a string, right? There's other ways you can define sky chords. You can define it using array index separately. You can do it as strings. You can do it as floating point numbers. You can do it as hours or degrees. You have to tell it what you did. So I have to tell it what the units are. And these are different. So the first one is units.hours, or unit.hour. And the second is units.deg for degrees. All right, so that'll define my sky position. And now I can do a search. So I can use VizieR to do this. So I'm going to define a, I want to do a search that's a little bit more advanced than just the standard search. So I'm going to say, I'm going to first define what parameters I want to search for. So I'm going to say VizieR, this is going to be my object that I'm going to search with. And to do that, to set this up, I'm going to use that VizieR object that we imported. And I'm going to instantiate it with the names of the columns that I want to retrieve. So I can optionally tell it I just want these columns, or it'll just give me everything by default. Okay, so I'm going to do a query. So let's say we think this is a galaxy. So I'm going to query a catalog called UGC, which is a catalog of galaxies. And I know in this catalog there is a name called UGC. That's the catalog number for each object. And I'm also going to query the RA index. So I could just use RA. I think there's an RA field in there. But I'm going to do something different. I'm going to do underscore RAJ2000. So when you search, when you do a query with VizieR, you can specify this value, and it will compute the coordinates in J2000 for you, the epoch or equinox J2000. This is important because the catalog, this is an old catalog, and the coordinates are probably in B1950. So I want the RA and underscore dec, so DE J2000. And one more thing, I want the distance. There might be more than one object, so I want it to tell me the distance of each object. This is another computed thing that VizieR does for you. So underscore R, that'll give you the radial distance from the coordinates you specify to everything that it finds in the search. Okay? And I can actually put a plus in front of there, and it'll actually sort by this column. So the table will be a sorted table in increasing order of radial distance, radial separation. So now we can run that, and the way we can do this is we can use this VizieR object that we just created, and we can run a function called query region. REG, okay? And I'm going to give it the position that I want to search, and I've already defined this as a sky chord object. And then I want to search in the catalog called UGC, and I'm going to do a search. I can set what radius I want my search to be, and so I'm going to do a radius of 10. Radius equals 10 arc minutes. So I need units arc min. Okay, and if I run this query, it'll check with VizieR. It'll find the UGC catalog, and it figured this out. It found this catalog. This is the proper name according to VizieR of that catalog, and it found 4 columns and 4 rows. I asked for 1, 2, 3, 4 columns. It found those, and there was 4 rows returned. To see what these are, I'm going to set this equal to a variable, tables, and then we can print out what the tables are. So again, there's actually a list. This is a table list object that's returning, and I want the first table because there's only one table here. So just give me the first table. I'll take the 0th element, and there's the table that we got. So here are the RA and dec in J2000. This is the the name in the UGC catalog of each object, and this is the separation in arc minutes from the coordinate that I specified. So you can see there's an object UGC 7654. It's an interesting name. And that object is the closest object. It's 1 arc minute, a tenth of an arc minute away from where I queried. So that is, we probably, we did find a galaxy, and now we know which one it is. That name may not ring a bell, UGC 7654, so we can actually ask NED to see if there's a more common name for this. So let's do a NED query now. So from astroquery.ned, import NED with, you guessed it, a capital N. And then we can do a query. So I'm going to do NED query object, because we do know a name. One name that we know is UGC 7654. And we can ask NED if it knows about that, and it does. So it returns some information, and it tells us the proper object name, or the most common object name, is Messier 87. This is M87, the famous galaxy in the Virgo cluster. Okay. So I've shown you how you can search different online resources, and you can do that in comfort of your own Python session. One last thing you might want to do is, if you are looking into an object, you might want to see if there's been any literature published on it. You might want to read about it. Not just, so more than just knowing the coordinates, you might want to see what people have written about it before. So there's one more service that you can use that's very handy. It's called ADS, the Astrophysics Data System. And this is what you can use to find different papers. There's this classic interface that I've been using for years, and they just recently came out with a newer interface. It's the Bumblebee interface. And that's the one I suggest you start learning, because that's the new and improved version. So you can search here for papers written by different authors or that are led by a specific author. You can do text searches. You can search for things in the abstract or limit your search by years. There's a whole kinds of options. There's some examples just shown right here on the front page. But if you want to do a search for papers about M87, you can just type M87. It'll do a query for you, and it'll load papers that are about M87. So here's a bunch of recent papers on M87. There's a lot. It's a popular object. You can click on one of these, and you can see a listing of the name, the title of the paper, the authors, and this is the abstract, give you an idea what the paper is about. If this seems like something that's interesting to you, there's links over here, so you can get the full publication, read the full paper. And there's some more information down here, the Universal resource link, and you can see who's referenced this paper and who cited this paper and what paper references, etc. There's a lot to do here. So that should get you started in doing queries. So make sure you explore all these tools and have fun.